at the binomial theorem and its importance in physics class. The binomial theorem and its importance for physics students, right? Now let us state the binomial theorem first. It states like, if n is any integer, n is any integer, the positive or negative, the positive or negative, or a fraction, or a fraction, and x is any real number, and x is any real number. Then we can write 1 plus x to the power n is 1 plus nx plus n into n minus 1 with 2 factorial with x square plus n with n minus 1, n minus 2 upon 3 factorial with x cube plus so on, where 2 factorial is 2 into 1, 3 factorial is 3 into 2 into 1, etc. Right? In general, n factorial is n with n minus 1 with n minus 2 with 3 into 2 into 1, etc. If x modulus of x is much smaller than 1, then 1 plus x raised to the power n is approximately 1 plus nx, right? And the first application of this we see in class 11th physics. Say the example here I need to explain to you is related to the gravitation. Okay, the acceleration due to gravity, the acceleration due to gravity at a height h, at a height h above the surface of the earth, above the surface of the earth. Radius of the earth, you take it as as r and is given by g dash is g into r square upon r plus h whole square. This is the formula for the variation of acceleration due to gravity. G dash is g times of radius square upon radius plus height whole bracketed square, right? Now if h is much smaller than r, for example, the radius of the earth is so big a quantity, and say we are considering a height above the surface of the earth which is considerably low, small, then show that the question is, then show that g dash is equal to g times of 1 minus 2h upon r bracketed, right? This is what is required to be proved, right? So g dash, as it is given here, g dash is g r square upon r plus h whole square. Now this can be written as gr square with r square taken out of the bracket, if r is taken common out, r square it will be, it is square of the bracketed one, so r square taken out, we can write 1 plus h upon r to the power 2. Am I right? Now this can be written as r square and r square can be cancelled out here. We cancel out r square and r square. Then we'll be getting g with, if I take the denominator to the numerator, 1 plus h upon r to the power minus 2. Am I right? Now here we use the binomial theorem. Using the binomial theorem, g dash will be g bracketed 1 plus, use the theorem now, like the formula where x is much smaller than 1. So 1 plus minus 2 with h upon r plus minus 2 minus 3 upon 2 factorial with h upon r whole square plus so on, right? As exactly you are applying your binomial theorem, see the similarity between this and this, okay? So this theorem is exactly applied here, and if as h is much smaller than r, the radius of the earth, h upon r is obviously very small, is very small, So the term containing the higher powers, so the terms containing the higher powers of h upon r can be neglected, can be neglected. Hence, g dash will be g with 1 minus 2h upon r. This is a common practical application in our class 11th physics, right? This is what we do, and look at here how the binomial theorem of maths, it is 1 plus x to the power n is 1 plus nx plus the factorial terms, right, is written here. Then you are applying directly in physics how the acceleration, the variation of acceleration due to gravity at a small height h, comparing your radius of the earth. Then approximation of the binomial theorem, or up to the first term, if you are looking at up to the first term, then you will be getting this formula, and approximation of this formula, this is the approximation of the formula, right? G dash is almost approximated to equal to g times of 1 minus 2h upon r, neglecting the higher powers, okay, got it? So this is how the binomial theorem is applied directly on our acceleration due to gravity's variation of small g at different heights. Am I right? Okay, good day.